This is R.D. Sharma solution, class 12, chapter 10. Differentiability exercise is 10.1. Now we have here, find whether the function is differentiable at x equals 1 and x equals 2. So this function, we have three partition actually. Till now, we have talked about the continuity, but here we will talk about the differentiability. Please remember d by dx of x is 1, d by dx of 2 minus x is what? 2 is 0, x is of course 1, so negative 1 it will be. What is the d by dx of negative 2 plus 3x minus x square? So it will be minus 2 will be 0 because it is a constant, 3x will give you 3 and x square will give you 2x. So 3 minus 2x is your differentiability. Now this f dash x, see, we have to check the differentiability. So what we'll do, we'll change the function fx to f dash x. I just told you what will be the differential, what will be the differentiation. So fx minus fc by x minus c, this is how we do it. But you don't have to worry about this because already the functions are given, we can just differentiate them. Okay, and what are the partitions? These partitions are, or you can say the intervals are different. Let us write this f dash x because we have just make the differential out of it. But we have to check whether it is differentiable at x equals 1 or x equals 2. Okay. So f dash x, I just told you differentiation of x is 1, differentiation of 2 minus x is negative 1, differentiation of negative 2 plus 3x minus x square is 3 minus 2x. This is when x was less than or equal to 1, this is when x is between 1 and 2, and this is when x is greater than 2. Okay. Now we will do the left hand limit and right hand limit, not for continuity but for the differentiability. We'll do the same thing but for differentiability. Okay. So this is left hand limit for differentiability, and we'll try to LHD we used to find out, but we have already taken the differential. So we will do the right hand limit and left hand limit for the differentiability, for the differentials, for the derivatives which we just found out. That is, we want a point and we want a tangent. We want to look for the tangent. So that tangent means the LHL has to be equal to RHL for the function which is given to us. Okay, you don't have to do anything for the constant. Whatever you do, if you use limit 1, because the function is 1, the differentiation of x is 1, so we are going to find out the differentiability at 1. So x equals 1 minus h, 1 x equals 1 plus h, you can write. So the first function, when you are 1 minus, that is you are behind 1, so it is just 1 because the differentiation was 1. Again here you have what is the value? Negative 1. So whatever you apply 1 plus h or whatever, it won't affect because it is already a constant, and 1 is not equal to minus 1 because there is no x in both of it. Left hand, right hand, there is no h. So 1 and negative 1, that means the left hand limit and right hand limit of the derivative of this function at x equals to 1 is not matching. It is not matching. Okay. Now coming to the point x equals 2. Now as I said, we have different partitions. So x is less than or equal to 1, 1 to 2 and greater than 2. So when we have to find out for 2, and when you go on the left hand side of 2, that is x equals 2 minus h, you are going to write, and x equals 2 plus h you are going to write. When you are below 2, it is 2 minus x, and differentiation of 2 minus x is negative 1. So again you don't have to do anything because it is a constant. You don't have an x there. So you cannot apply a limit, you can do anything. It is negative 1 always. But in the differentiation of minus 2 plus 3x minus x square, which is 3 minus 2x in our case, so we will put 2 plus h here. So you'll get 3 minus 2 to the 4 minus 2h. Now you apply the limit h tends to 0, this goes 0, 3 minus 4 is negative 1. Now you see the negative 1 left hand limit and right hand limit for the differentiation at x equals to 2 is equal. That means the function is differentiable at x equals 2. It was not at 1, but it is at 2. This is how you're going to write, okay, in your examination or in your paper. Show that the function this is continuous but not differentiable at x equals 1. So we have two different functions. Actually, it is three different functions. This function, the first function is mod 2x minus 3, and then we have the greatest integer function. If I can see it clearly, the greatest integer function of x when x is greater than or equal to 1, that is when you go up x. When you go up 1, it is going to be this function. When you are below 1, then which function are you going to use? You are going to use this sine pi x by 2. Okay. So you have to, the question is asking, you have to find out that this is continuous but not differentiable at x equals to 1. So we will check the continuity first. So at x equals to 1, we'll find out the left hand limit, we'll find out the right hand limit. The left hand limit will be x equals 1 minus, or you can say 1 minus h you can put, and x 1 plus h you are going to put. You can just write it as 1 plus, that is equivalent to 1 plus h, or 1 minus is 1 minus h. Okay, when you go below 1, it is going to be sine pi x by 2. Sine pi, in place of x, just write 1 minus h, because that's what you have to put, because you're going just backwards of 1. So sine pi by 2 minus pi by 2 h. So sine 90 minus theta it is. See, it is pi by 2 into 1 minus h. So I just multiplied it inside. Pi by 2 minus pi by 2 h. Sine 90 minus theta is cos theta. You can put h0 there, or you can put h here also. That is, if you apply the limit here only, that is pi h by 2, you apply limit here, then sine pi by 2 will be equal to, because it will be sine 90. Sine 90 is 1. Or the better way is to do the cos. So cos sine by 90 minus theta is cos theta, cos pi h by 2. When you apply limit h tends to 0, it is going to be 1. Cos 0 is 1. Coming to the right hand limit for the continuity at x equals to 1, we will put a 1 plus h in this mod 2x minus 3. So 2, I am writing 1 plus h here, minus 3, and the greatest integer function, we are going to put x as 1 plus h. Now you have to know the property of the modulus and the greatest integer function. So this is 1, this is 2, 3. So in this greatest integer function, whichever value is between 2 and 3, it will go to 2. Whichever value is between 1 and 2, it will go to 1. So 1 plus h means very small value added to 1. So it will always go to 1. So greatest integer function will give you result of 1. How about this h tends to 0 for mod of this? I hope you got the idea. Modulus of this. Please remember, you are below this greater than 1. Okay. So you are greater than 1 and you are using just 1 plus h. It's very small value addition of 1. So I'm just opening it, 2 into 2h minus 3. So this 2 minus 3 is negative 1, 2h minus 1. Apply h equals 0. So you are going to get negative 1 in the modulus, it will be 1. 1 multiplied by 1 is 1. So the left hand limit and right hand limit are equal. LHL and RHL are equal. So this function is continuous at x equals 1. Right? It is continuous at x equals 1. Now let us come to the probability, differentiability, sorry. So continuity we have shown already. Now differentiability we have to show. Because continuity doesn't mean or doesn't guarantee the differentiability, but differentiability guarantee continuity. You would have checked for differentiability, but for that you have to go, if it is differentiable, not differentiable, you have to go back to continuity. But we are checking the differentiability. Simple definition of differentiability is fx minus fc by x minus c, limit x tends to c, c minus will do, c plus will do, that is on the left hand derivative, right hand derivative will find out, and try to find out whether the value matches or not. So at x equals to 1, left hand derivative I am taking, on right hand derivative I am taking, of course you have to do the same thing, 1 minus h and 1 plus h. You have to write the same function, that is fx minus fc by x minus c. This is nothing but the solution of differentiation by first principle. This is just first principle method. And since we have this c as 1, so I'm just putting as 1. Again, fx minus fc divided by x minus 1, because your c is 1 in this case. Okay, what is the value of, because the function when you have x greater than or equal to 1, this function you are going to use. So here on the right hand side, right hand derivative, you have used 1 plus, left hand derivative is 1 minus. Okay, so you have to see which function you have to use. When you are above 1, x equal, you can say x 1 plus or 1 plus h, left hand derivative 1 minus h or 1 minus, you can say. So fx will be, in the left hand derivative, it will be sine pi x by 2. Sine pi x by 2. Sine pi into x, in place of x, write 1 minus h by 2 and minus f1. Now f1 in both the cases will be same. f1 will be what? See, where is the equality? X is greater than or equal to 1. So equality is here. So x is greater than 1, x is equal to 1. That means x is greater than or equal to 1, which we have to use here. So just put it here. 2 into 1 minus 3. And greatest integer function of 1 will be 1 only. It is already a integer function. Integer. So 2 minus 3 is negative 1. Modulus of negative 1 is 1. So minus this 1 into 1 is going to be 1. So in both the cases, LHD and RHD, I am going to put 1. Here also same thing. Fx, because you are going to right hand derivative, so you are going to use this one. Modulus of 2, and in place of x, just write 1 plus h and minus 3. And then you have this greatest integer function of 1 plus h minus 1 by x minus 1. Now you can very well see that x minus 1 in the denominator. So you will get certain thing that may, cancel this x minus h. But x is what? 1 minus h in the left hand side, 1 plus h in the right hand side. So denominator of LHD will be negative h, and right hand side, right hand derivative, the denominator will be h. Now let us apply the limit. Limit h tends to 0 is everywhere. I am not writing it, but that is why I have shown you the example or answer. That is, you have to write it always. Now sine 90 minus theta is cos theta, because now you cannot put h limit directly. It is this sine something is combined with negative 1. So you will write sine pi by 2 minus sine pi h by 2. This is sine 90 minus theta. It is going to be cos theta, cos pi h by 2. So cos pi h by 2, and you have negative 1 also. Now 1 minus cos theta is simply 2 sine square theta by 2. So this cos h by 2 minus 1 divided by negative h. Since we have a negative in the denominator, let us change the position of 1 and cos pi h by 2. Please remember, 1 minus cos theta is always 2 sine square theta by 2. That we will apply here. Okay. Then we'll use this negative h and whichever to solve the situation. So I am taking the negative out, or you can say multiplying negative 1 numerator denominator. It will be negative 1 minus cos pi h by 2. In the denominator you have a negative h. Negative negative gets cancelled. So 1 minus cos pi h by 2 is 2 sine square pi h by 2. 2 sine square pi, this is not cos, just cancel this cos. Pi h by 2 divided by 2, pi h by 4. So you need pi square h square by 4 square in the denominator. You need pi square h square 4 square in the denominator, and that will be multiplied to the numerator also. Because you need sine theta by theta, and sine theta by theta is going to be 1 sine, this is okay. So pi square h square by 4, pi square h square by 4 you need in the numerator also. So you already have h in the denominator, you have to have a h again in the numerator. Okay, there is one h already. Now this is whole going to be 1. Sine theta by theta is 1. So what do you get? Limit sine theta by theta equals 1. So this is going to be 1. And whatever is there, 2 into pi square by 4 square, or 2 into whatever constant is there, there is always an h here. There is one h, and when you apply the limit, whatever constant comes, limit h tends to 0 is 0. So this LHD has come as 0. What it has come? It has come as 0. Now coming to the right hand side. Now we have to just see whether it comes equal to 0 or not. If it comes as 0, it is differentiable at x equals to 1, otherwise not. Okay. Now 2 into 1 plus h minus 3. Now remember, here is a catch. The catch is when you multiply this 2 with 1 plus h minus 3, it will be 2 plus 2h minus 3. What do you get? Minus 1 plus 2h. Minus 1 plus 2h, but you are talking about 1 plus h. You are greater than 1. And once you are greater than 1, 2x minus 3x is 0 when x is equal to 3 by 2. That is 1.5. So you are already above 1. Okay? So you are above 1, but a little bit 1. Very little bit 1. So you have to convert it into negative. So modulus, when it will open, it will be negative. This is only the catch of this question. So when you open it, it will be negative of it. Okay? When you open the modulus, it will be negative of whatever is inside the value inside. So you get 2h minus 1 in the inside, but when you open it, it will be negative of this. So you get 1 minus 2h, 1 is already there. You have h in the denominator, this gets cancelled, h also gets cancelled, minus 2 is there. So the right hand derivative comes as negative 2. Now you see 0 and negative 2, they are not matching. That means this function is not differentiable at x equals 1. Though it was continuous, but it is not differentiable at x equals 1. Okay? So the continuity computation may be different from the differentiability definition, because in the differentiability you already have a 1 along with this function. So you cannot just put h0 here. You have to solve all along, and then you have to put this as combined function. Similarly, what we have done, cos h pi plus pi h by 2 minus 1. So this is a combined function. That is why we converted it into 2 sine square h by 2 or 2 sine square theta by 2. So I hope you got the idea. How did we arrive at this? The continuity is explained, but the differentiability is not, because it is 0 and minus 2. When you go to left, when you go to right, you get different result. Okay? So this kind of question, it has modulus, it has a greatest integer function, it also has the sine one. Okay, sine pi. So 3 functions are there, and you need to know the property of all of this, and with the intervals also. This interval is x greater than or equal to 1 or x less than 1. Now if fx is equal to ax square minus b, if mod x is less than 1 and mod x is greater than or equal to 1, it is going to be 1 by mod x. If this is differentiable at x equals to 1, find a and b. So the question is saying this is differentiable. It is saying differentiable, you have to find out the value of a and b. Now you already know what is the explanation for mod x. So mod x less than 1 means what, and mod x greater than 1 means what. So when mod x is less than 1, what is this? When you have mod x greater than or equal to 1. See, mod x less than 1 means it is between minus 1 and 1. But mod x is greater than or equal to 1. That means you are between, not between minus 1 and 1. Okay? Mod x greater than or equal to 1 means you are not counting anything between minus 1 and 1. But mod x less than 1 means you are counting values between minus 1 and 1. Okay? So 3 partitions there, x less than minus 1, x greater than minus 1, and here we have x between negative 1 and positive 1. So x is between negative 1 and positive 1. Okay. So there are 3 different parts. So you have to write the function for all these 3 parts. Okay. When you open this mod x, there will be 2 conditions for this mod x as well. I hope you got the idea. So let me just show it to you here, that this actual function we are changing it. Okay, for fx. So when x is less than negative 1, when x is greater than x is greater than 1, it is not minus 1, it is 1. Just change, there is a correction, slight correction here. So x is less than minus 1, x is greater than 1. So this is going to be 1. Okay. So I'm just changing it. So when you are greater than 1, it is going to be 1 by x. When you are less than minus 1, it is going to be negative 1 by x. Why? You have a mod x here. Mod x is simply x is greater than 0, it is x. X is less than 0, it is going to be minus x. How about 1 by mod x? It will be 1 by minus x and 1 by x. And in which range we are talking about? We are talking about mod x. So mod this x less than minus 1, it is going to be minus 1 by x. And when x is greater than or equal to 1, it is going to be 1 by x. I hope you got the idea. You have to understand the both mods very well so that you know how we have achieved this answer. And how about x between negative 1 and 1? It is going to be ax square minus b. X between negative 1 and 1, it is ax square minus b. Now, all these differentiable function, we know every differentiable function is continuous. So it is already given in the question that it is differentiable at x equals to 1. So it is continuous also. So it is continuous at x equal to 1. So x equals to 1, we will find out the left hand limit, right hand limit, and we will equate them. That is, you have to write 1 minus, that is 1 minus h, 1 plus, that is 1 plus h, of course. So we don't need it because the questions are already, the functions are separate. We have separated them already in different intervals. We have removed the mod x now. So we know at each interval what will be the value. Okay. So you have this ax square minus b here. And for this, when we just go a bit higher than 1, it is going to be 1 by x. So just apply the limit x tends to 1. Here also x tends to 1. You have this, when you put x as 1, you get a into 1 square minus b. So 1 square will be 1 only, so it will be a minus b. This is a minus b. Here you have 1 by 1, that is going to be 1. So left hand and right hand, it is a minus b and 1. Now just equate it. So it is continuous, that means LHL should be equal to RHL, a minus b equals to 1. Right? Now this is the first equation and we are going to use it. A minus b equals 1, we are going to use it just now. Just keep in your mind that this is our function or the relationship which we got. Now coming to the differentiability, we have just checked for the continuity. Let us check for the differentiability. So we will try to find out the left hand derivative. We will try to find out the right hand derivative. Fx minus f1 divided by x minus 1, because x equals to 1 is already given in the question. Fx minus f1 by x minus 1, this is also given in the question. So we have limit x tends to 1, you can say 1 plus and 1 minus. So LHL or LHD you write 1 minus 1, RD you write 1 plus. So when you go above 1, below 1 what is there? Ax square plus b. See, minus 1 to 1, it is ax square plus b. When you go 1 plus, when you go above it, you have to use 1 by x. So we will use 1 by x here, right? So x greater than or equal to 1, x equals to 1, x equals to 1, 1 by x. F1 is 1 by 1, that is going to be 1 because equality is from 1 by x. So f1 will be 1 in both the cases, divided by x minus 1. Here x minus 1 in the denominator, what is going to be fx? We are going above 1. So what is above 1? X is greater than 1, so you have to use 1 by x here. So let us use 1 by x here. Okay. This limit x tends to 1 will always be there. I am not writing it, but please remember limit x tends to 1 is already there. Let us solve the right one. 1 minus x by x divided by x minus 1. So what do you get here? You can change the sign, minus 1 minus x. X minus 1 in the denominator, you have x here. This gets cancelled, you get minus 1 by x, and since x is tending to 1, the limit is 1. Just replace x by 1. Okay. So see, minus is in the numerator, x minus 1 gets cancelled. So you have a minus 1 by x, and x is of course tending to 1. So you get a negative 1 here. The left hand derivative, we have ax square plus b minus 1. Now we have to get something in the numerator so that you get x minus 1 cancelled. But we are not getting it. Why not to take the advantage of what we have found out in the first discussion? That is, when we were doing the continuity, we already found a minus b equals 1. Remember? So this b can be written as a minus 1. A minus b equals 1. In the place of b, you can write a minus 1. So in place of b, just write a minus 1. And minus 1 is already there. But it is not ax square plus b. I have already, see, I have done again a mistake. I am so sorry about that. Ax square plus b, it is not ax square plus b, it is ax square minus b. So when you put minus b, this will be negative a plus 1. And denominator, you have x minus 1. So by this step, I know that I did a mistake. I committed a mistake. And that mistake is simply I used ax square plus b, which is not the correct one. Ax square minus b I have to use. So this, I'm just changing it. This is, I'm changing the sign also now. So x square minus b and ax square minus, in the place of b I replaced with a minus 1. I'm doing it again just to re-emphasize that what was the mistake. X square minus a plus 1 minus 1 gets cancelled. You can take a common from here, you get x square minus 1. You can call it as x square minus 1 square. It is a square minus b square, a square minus b square, a minus b, a plus b. So into x minus 1, x plus 1, denominator you have x minus 1, you can get cancelled, a into x plus 1. Okay. So when you apply the limit, x tends to 1, it is going to be a into 1 plus 1 is 2, 2a. Now LHD is 2a, RHD is negative 1. Remember? Since it is differentiable, so you can always equate the left hand derivative with the right hand derivative. Just equate it. 2a equals 1, negative 1, a is equal to minus half. So when you get a as minus half, you already have a minus b equals to 1. Put it in this equation. Minus half minus 1 is minus 3 by 2. So b is negative 3 by 2. A negative half, b negative 3 by 2. Okay. This is how you can compute it. Okay, this is all about this discussion. We'll be taking this question in the next one. Till then, thank you so much. Take care of yourself.